All right, we're going to pick off where we left the other day on compound inequalities. A compound inequality is like a regular inequality, but there are two. And it's joined by an and or. All right, then we have a couple examples here. So 3 is less than or equal to x is less than or equal to 7. We can rewrite this as x is greater than or equal to 3 and x is less than 7. All right, and the reason we do that is because when you put x first, so like this part, we actually flip the entire thing, so we have to flip the symbol to be greater than. So when we graph this, we need to put 3 and 7, so now we have to put two numbers on our line, not just one. So there are going to be two dashes. The smaller number goes on the left, so 3 is smaller than 7. And then we just graph them separately, basically. So if we graph x is greater than or equal to 3, greater than or equal to means it's a filled-in circle, or equal to. And where are the numbers greater than 3? The numbers are greater than 3 to the right. So this is going to go to the right. Okay, and then we have x is less than 7. So less than would mean it's going to be open, and numbers less than 7 go to the left. So these arrows point towards each other, which means it's shaded in between here. Okay, so they're shaded in between towards each other. And a little comment we can make here is and is like a sandwich. Okay, a little comment I made over here is that and is like a sandwich because they go towards each other and it's going to be shaded in between there. Okay, the next one is an or. So we're going to graph these two separately, so put your two dashes on here. We need to put 5 and 1 on there. 5 is bigger than 1, so 5 will go to the right, 1 will go on the left. So you look at the 5, x is greater than 5, so open circle, and it goes to the right because that's where the bigger numbers are. And then x is less than or equal to 1, so it's shaded in at the 1. And less than 1 will go to the left. Less than goes left. Okay, so the ors, so or looks like, oops, I can't spell. The oars of a boat. So ors will point away from each other, ands will point towards each other because they're a sandwich. Okay, so now there's compound inequalities have two graphs, two inequalities. They either point towards each other or they point away from each other for the ands and the ors. Okay, so in example 1, solve the compound inequality, and it says then graph it to the right. So if we're going to solve this, we can do it two ways. You can write it separately as two different inequalities, or you can kind of do all the steps at once. I'm going to do them all at once because it just saves some time and saves some room. So if you look on the inside, right in here, that's where the variable is, and that's what you want to get alone. So if you were to solve for y, the first thing you would do is minus 4. So we have to minus 4 from inside, and we also have to minus 4 from the left and the right side. So you would have negative 13 is less than 2y less than positive 2. So subtract 4 from everywhere. And the next step would be divide everything by 2. So negative 13 divided by 2 would be negative 6.5. We're left with just y in the middle. And then 2 divided by 2 is 1. Okay, so what we have now is two numbers. We have negative 6.5 and 1. So negative 6.5 is smaller, so that goes to the left, and 1 goes to the right because 1 is bigger. So now, if y is less than negative 6.5, it's an open circle. Less than means you go left. If y is less than 1, open circle, I'm going to go to the left. So these both go to the left, which doesn't happen very often, but what that means is when you shade it, it would be everything to the left of 1. This does not happen very often, but in this case it did. Okay, example 2, solving for x, then we're going to graph this. So this is an OR. So solving the left one, to get x alone, you would have to subtract 7. To get negative 2x is less than negative 4. To get negative 2x is less than negative 4, then we divide by negative 2 to get x. And I'm going to make a comment right now. Divide by negative. What that means is we flip our sign. So I put that in there because we have to remember to flip the sign when you divide by a negative. So when you divide by negative 2, you flip your symbol. So it's x is greater than positive 2. And then solve the one on the right. So you subtract 5. You get 3x is less than or equal to negative 3. And we divide by a positive 3, so it doesn't flip. X is less than or equal to negative 1. So we have x is greater than 2, or x is less than or equal to negative 1. So we put these numbers on there. If it's 2 is bigger than negative 1, so 2 goes to the right. So start with x is greater than 2. It's open circle. Greater than means you shade to the right. Or x is less than or equal to negative 1 is filled in circle, shade to the left. So these point away from each other, and that's what it's going to look like. All right, and then we have 2 more. Example 3, we're solving. Let me change colors for this one. So we have 5 is greater than or equal to 3x minus 4 is greater than or equal to 8. So we can solve this all together as we go. So I'm going to put my lines down here. The first step to get x alone would be add 4. So we have 9 is greater than or equal to 3x is greater than or equal to 12. Okay, and then continue your lines down. How do you get rid of the 3? Divide everything by 3. So 3 is greater than or equal to x greater than or equal to 4. So this would be the solved inequality. So we got to put our numbers on our graph. 3 goes left of 4 because 3 is smaller than 4. And now when we graph this, if you graph the first part, this is 3 is greater than or equal to x. How you would read that is, it would really mean x is less than or equal to 3. So it's filled in, and it goes to the left. Okay, the second part reads x is greater than or equal to 4. So you fill that in, because it's greater than or equal to, and greater than means it goes to the right. So these are point opposite directions. Okay, and then again, I just want to point out that when you read this part, I always like to flip it and put the variable first. So I would flip it and say x is less than or equal to 3 instead of keeping 3 in the left and x in the right. Okay, and then the last example, another OR statement. So solve the left one. Get rid of the plus 4, we minus 4. 6y is less than 6. Divide by 6 to get y is less than 1. And then we solve the one on the right. You would add 11 to get 2y is greater than or equal to 26. Divide by 2 to get y is greater than or equal to 13. So if you read this, it would read y is less than 1 or y is greater than or equal to 13. So when we graph them, the 1 is smaller and 13 is bigger. So 1 goes on the left, 13 goes on the right. If we graph the blue one, it says y is greater than or equal to 13. So it'd be a filled in circle because it's greater than or equal to, and greater than means point to the right. If you graph the green one, y is less than 1. Less than means open circle, and less than would be the numbers to the left. So that's how that last one would look. So it's pretty similar to what we did the other day where we graph them, just that we're solving and you have two different arrows.